Hello, this is an interesting radical problem. Square root of n to the power of 3 equals square root of 5 to the power of 3. We are solving for all values of n that will satisfy this equation. So let's start. If you have square root of a, this is just like writing a to the power of 1 over 2. That means square root of n power 3 is just like writing n power 3 raised to the power of 1 over 2. And square root of 5 power 3 is just like writing 5 power 3 raised to the power of 1 over 2. Remember, a power n raised to the power of m equals a power m raised to the power of n. So let's switch the powers. I'm going to have n power 1 over 2 raised to the power of 3. And this equals 5 power 1 over 2 raised to the power of 3. Don't also forget that a power 1 over 2 is the same as square root of a, right? So we have square root of n raised to the power of 3 equals square root of 5 raised to the power of 3 is raised to the power of 3. We can form this cubic equation by moving this backward. We have square root of n raised to the power of 3. This becomes minus square root of 5 raised to the power of 3, and this equals 0. To expand this and make use of this cubic identity, a power 3 minus b power 3 equals a minus b times a squared plus ab plus b to the power of 2. Meaning my a is root n, while my b is root 5. So I'm going to have root n minus root 5, that is a minus b, times a squared, that is square root of n to the power of 2, plus ab, that is square root of n times square root of 5, plus b squared, that is square root of 5, raised to the power of 2, and this equals 0. Now, I can simply have square root of n minus square root of 5. This cancel this. I have n plus this times this. I'll have square root of 5n plus this cancel this. I have 5. And this equals 0. We equate each of these to 0. I'll have square root of n minus square root of 5 equals 0. I'll have n plus square root of 5n plus 5 equals 0. We solve these individual equations. To start with this one, I move this over here. I have square root of n equals square root of 5. Square root eliminates square root, meaning n equals 5. That's my n1. To solve this, I move n over here. I move 5 over here. So we'll have just square root of 5n equal, this is negative 5 minus n. I take the squares, output part of this equation again. This cancel this. I have 5n equals, for this, I take the squares. So this is 5n equals this, negative 5 times negative 5, this is 25. Negative 5 times negative n plus 5n. Negative n times negative 5 plus 5n. Negative n times negative n plus n squared. From here, our 5n equals, this is 25. plus 5n plus 5n, that is 10n plus n squared. I move 5n over here, I have 0 equals 25 plus 10n plus n squared minus 5n. From here, I have 0 equals 25 plus 10n minus 5n, and 5n plus n squared. I rearrange this. I have n squared plus 5n plus 25 equals 0. To solve this quadratic equation, we need to use formula method. I write the formula in respect to n. F n equals negative p plus or minus square root of p squared minus 4 times ac divided by 2a. One is the equation of n squared, that's my a, this is my b, this is my c. So from here, I will have n equals negative p, negative 5 plus or minus times square root of, this is 5 power 2 minus 4 times 1 times 25 divided by 2 times 1. From here, I have n equals negative 5 plus or minus square root of, this is 25 minus 100 divided by 2. From here, I have n equals negative 5 plus or minus square root of, this is minus 75 divided by 2. So from here, I have n equals negative 5 plus or minus, there's minus here, I have square root of negative 1 times square root of 75 divided by 2. So from here, I have n equals negative 5 plus or minus square root of negative 1, is I times square root of 75, this is square root of 25 times 3 divided by 2. I have n equals negative 5 plus or minus I times square root of 25 times square root of 3 divided by 2. So from here, I have n equals negative 5 plus or minus I times square root of 25 is 5 times root 3 divided by 2. I can factor out 5 over 2 from here. I have n equals 5 over 12 negative 1 plus or minus I root 3. So we have two complex values for n. My n2 will be 5 over 2 because I've gotten n1 already. I take the plus, while my n3 will be 5 over 2 of negative 1 minus I root 3. These are the two complex values for n. And we have one real value for n, which is n equals 5. If you insert this value for n, you have the equation. This is 5 to the power of 3. Remember, n equals 5. And this also is square root of 5 to the power of 3. This is square root of 125. That is 5 times 5 times 5. And this equals square root of 125. So this has satisfied the equation. Thank you.